Good afternoon, Algebra 1. So what we're going to do today is we're going to continue with radicals. So before we start anything, I do want us to do a little bit of a refresher, where if I gave you the square root of 45 and asked you to simplify it, what we first do is think about any perfect square that goes into 45. So we could sit around here and play with it all day, but perfect square that works is 9 times 5. Can't really read that, but that's fine. And so then what I do is I know that 9 breaks down to a pair of 3's, so I take one of those 3's to the outside, and my answer would be 3 square root 5. For number 2, it's looking for the cube root of 32. So we're going to think of our perfect cubes that go into 32. We have 8, 27, and then none of the ones above that really work. 8 is the only one that does go into 32, and I know that when I break that down, it's going to be 8 times 4. 8 is 2 times 2 times 2, so I'm going to bring one of those 2's outside, put my 4, and write the little 3 for my index. Now number 3 is something a little different. We have done substitution of certain values, like if I said, A is 64, we're going to end up plugging A, and we've done that before, but we have not done that with square roots. So what this would look like is I'm going to plug the 64 in for A, so I have negative 3 cube root of 64 minus, on the outside, not on the inside, b squared. So b squared is negative 2 all squared. So if I were to evaluate this, the cube root of 64 is 4, so I'm going to have negative 3 times 4, if you want to write in parentheses you can as well, minus negative 2 squared is going to be a positive 4. So notice I'm not making those two positive, instead I'm just making the negative 2 once I square it positive and keeping this minus sign right here. So I have negative 3 times 4 minus 4, which is going to be negative 12 minus 4, which is going to be negative 16. So that's a little bit of review from stuff that we've done before, but also throwing in some of the new square root stuff. But today's video is going to focus on adding and subtracting radicals. So what we're first going to do is we're going to determine what like terms looks like for radicals. So like terms, you have the same index and the same radicand. So what that means is that your index is going to be the little tiny number that is right next to your square root sign. So you want to make sure that those look the same, and the radicand is the number underneath of your radical. So for example, for number 4, if I want to look at ones that are similar, I first want to make sure that they all have the same index. So if I'm looking across here, I'm going to look for everything that has either a 2 or a 3, because we don't have anything higher than that right here. So if I want to look for all the ones that are similar to this first one right here, I have the possibility of this second one, the third one, or sorry, that's the fifth one, sixth one, seventh one, eighth one. Right? These are all possibly ones that are the same because they have that same little index next to it. Notice those other two, 3 root 5 and 5 root 3, they have the same index as each other. However, their radicands are not going to be the same on the inside. The number inside is not the same, so therefore those two are not similar. Now as I go forward, I'm going to make sure that the number underneath my square root sign is the same. So the first one is similar to this third one, which is similar to this one, which is not similar to 5 times the cube root of 2, because there's not a 5 underneath, and then it's similar to the last one. So the only ones that are similar are the ones that are circled, because they have exactly the same index, the 3, and then they have a 5 underneath the radical. So as I keep going, if I look down here at number 5, if I want to find ones that have like terms, what I have to notice is that this first one and this second one, those are different. Even though they both have a 5x next to it, they are not exactly the same, because 5x squared underneath that radical is actually going to be different than what 5x is. So if I were to go through here, kind of do some looking around, I notice that the first one and this fifth one are the same. So they both have a 5x squared underneath, and they both have a little invisible 2 as their index. So this is important because as we move forward, and as we move on to the back right here, when we go to add, we have to make sure that our radicals have the same index and that they have the same radicand underneath our radical before we can add them. Okay, so what this would look like is if I am going to take number 6, how I'm going to add and subtract is I'm not going to add or subtract anything on the inside. That's going to remain the same. Instead, what I'm going to add or combine are all the terms in front. So I'm going to have a 3, the negative 4, and the positive 7. So the way that I can combine these, the way I could write this, is I could write it in parentheses, 3 minus 4 plus 7, all in parentheses, and then keep my square root 2x. This way I know that I'm going to evaluate everything in the parentheses, and then have my 2x at the square root of 2x at the end. So then 3 minus 1 is negative 1, plus 7 is 6, square root 2x, and that would be my final answer. So, what we should always do before this, before we go ahead and add or subtract, is look and see if you can simplify, because you're not always going to have, like for number 6, they were all in simplest terms, but as we start to look at number 7, we don't have everything in simplest terms, because if we just looked at 7, we'd say, oh, it doesn't look like the radicand is the same for all these, we don't have to add them together. Well, that's not necessarily true. If we went and simplified them, we may end up with all the same radicands. So, I guess one question that you should always ask yourself first is, can I simplify? If you can simplify, of course you should do it. If you cannot simplify, then you should say, which of my radicals can I add together? Which ones already have the same radicand in it? So if I go and look at the square root of 8, if I were to break that down a little bit further, I know that a perfect square that goes into it is 4. And so 4 is going to give me a pair of 2's. So the square root of 8 is now going to look like 2 root 2. I'm going to leave the middle one because it is in simplest form. And I'm going to have, it should be a 2. Let me rewrite that. And then the square root of 50, I can break that down into 25 times 2 and pull out one of my 5's. And so now what I can do is this now looks like what I started off with for number 6, so I can go and add all those in the beginning. I can add up each of my numbers that are in front of the square root. And so 2 minus 1 is negative 1, plus 5 is going to be 4, square root 2. And one way that you could always check this is on Desmos or any sort of calculator that you might have, and you can plug in the top answer and see if it's the same decimal as what you get for my boxed in answer down there. Alright, so we're going to do the same process for number 8. And so I'm going to look and see, can I simplify any of these any further? Now notice we're dealing with the cube root for the first part of this, and then we're dealing with the square root for the second part of this. So what we have to notice is I cannot combine these. The indexes are different, so there's no way that I'm going to be able to combine them. So what I'm going to do is I'm going to see if I can break down the first one, the cube root of 24 first. And I know that 8 times 3 is going to get me 24. 8 is a perfect cube. It's going to be 2 with 3 on the inside with the little 3 as my index, minus 5 cube root of 3, which is perfect because that is exactly what I needed. And so if I just wanted to go ahead and simplify what I have in orange right here, I could say I'm going to do 2 minus 5 with the cube root of 3. 2 minus 5 is going to be negative 3, so it's going to be negative 3 cube root of 3. Alright, so again, you don't have to go ahead and simplify it all the way down like I just did. I just figured we were kind of doing it anyways, so we should go ahead and complete it. For the part in purple, I'm going to see if I can break these down a little bit further. So 98, 49 times 2 is going to get me 98. 49 is a perfect square. 7 times 7. So when I go to write this, I'm going to have a 7 root 2. For 50, that breaks down into 25 times 2. 5 is my perfect square. Now, the only thing we have to notice is I have a 2 on the outside. So already what this reads is it reads 2 times the square root of 50. So when I go to simplify the square root of 50 into 25 times 2 and bring out one of my 5's, because remember it breaks down to 5 times 5, one of these 5's is going to multiply by that 2 when you bring it out to the front. So out front, instead of just having the 2, now I'm going to have a 10 on the outside. It would have originally been 5, but because I already had a 2 out there, I have to multiply them together. And so now I would go ahead and combine these, so I have 7 plus 10 times the square root of 2, so I'm going to be left with a positive 17 square root 2. So your final answer is not going to be two separate answers, you're going to combine them at the end, so whatever that sign is in between, because we had a positive 7, my final answer would be negative 3 times the cube root of 3 plus 17 times the square root of 2. And that would be my final answer. So, as always, if you have any questions, please feel free to let me know, and have a great rest of your day.